Math 83, Unit 1, Lesson 7. We're going to solve linear inequalities. But before we start, I want to give you an example of what an inequality would look like. 3 is less than 7, and that's a true statement. 3 is a smaller number than 7. If I were to take both sides of this inequality and multiply them by -1, so I'm going to multiply -1 by 3 and then -1 by 7, we get -3 less than -7. Well, this is a false statement. -3 is actually bigger than -7. So the true statement would look like a -3 is greater than -7. So this is what's true. And this one's true. So therefore, anytime we multiply or divide an inequality by a negative number, we're going to change the direction of the inequality. Other than that, you solve all inequalities just like they were equations except for that one little fact. Anytime you multiply or divide by a negative number, you're going to change the direction of the inequality. So, example number 1. The first thing I would do is to get rid of this -12, and I do that by adding 12 to both sides. We get a 5x, this -12 and plus 12 go away, less than or equal to, and then 3 plus 12 is 15. Our last step then is to get x by itself. We divide both sides by 5. Those 5 divide out, and then we have x is less than or equal to 3. Because we divided by a positive 5, we leave the inequality alone. In number 2, we're trying to get x all by itself. So first thing to do is get rid of this -28. So we're going to add 28 to both sides, and we get a -4x is greater than 0 plus 28 is 28. Now here, we're going to have to divide both sides by -4. I divide the left by -4 and the right by -4. And because I divided by a negative number, we're going to change the direction of the inequality. It's now going to go from a greater than to a less than. And then 28 divided by -4 is -7. In number 3, we have an n term here on the left and an n term here on the right side of the inequality. So we have to get them together. I always try to get them together on the left-hand side. So we're going to go ahead and subtract 3n from both sides. Therefore, 3n minus 3n goes away. 6n minus 3n is 3n. And we bring down the rest. Now we're going to get our constants together on the right-hand side. We do that by adding 17 to both sides. And we get 3n is greater than or equal to 36. And then our last step is to get n by itself. We do that by dividing both sides by 3, and we get n is greater than or equal to 12, because 36 divided by 3 is 12. Now, we divided by a positive number, so we leave the inequality alone. In number 4, we're going to do the same thing, because we want to get the x's together on the same side, and I always now with inequalities try to get them on the left-hand side. So I'm going to add 2x to this side and to this side. Therefore, this minus 2x and plus 2x goes away, and we have -3x plus 2x is going to be a -x plus 5 less than or equal to 1. Now we're going to move the 5 over, and we do that by subtracting 5 from both sides. 5 minus 5 goes away, and we bring down the -x greater than or less than or equal to 1 minus 5 is going to be a -4. Now, to get x all by itself, this negative in front is just like a -1 that's in front. So we're going to divide both sides by -1. And because it's a negative number, that's going to change the direction of the inequality. So this becomes x, change this direction to be greater than or equal to, and then -4 divided by -1 is going to be a +4. In number 5, this time we have these x terms together on the left-hand side, so we just have to go ahead and combine like terms. We can go ahead and add those together. So negative 8x plus 2x is a negative 6x. Now we're trying to get x by itself, so we're going to have to move that 13, and we subtract 13 from both sides to do that. The 13 minus 13 goes away, and we get a negative 6x is greater than, and then 1 minus 13 is going to be a negative 12. Now our next step is to get rid of this negative 6. So negative 6 times x, we're going to do the opposite and divide both sides by negative 6. Now we have a negative number, and because we divided by a negative number, we're going to change the direction of this inequality from greater than to less than. And then negative 12 divided by negative 6 is 2. In number 6, we're going to do the same thing we did with equations. Whenever we see parentheses, we're going to go ahead and distribute. So we get a negative 3y, and then we have to do negative 3 times 4, which would be negative 12. We have our y here. We're trying to get alone, so we're going to move that 12 over, and we add 12 to both sides. And we get negative 3y is less than, and then negative 24 plus 12 is a negative 12. And here we go, another negative number. We're going to divide both sides by a negative 3. And the fact that we divided by a negative number is going to change the direction of the inequality. So here's our y. And then instead of less than, it's going to switch to greater than. And then negative 12 divided by negative 3 is 4. In number 7, the first thing we have to do when we see parentheses is to go ahead and distribute. So I'm going to rewrite the rest. 1 plus 3n is greater than or equal to, we'll distribute the 4, 4n, and then 4 times negative 1, so we'll have a minus 4 plus n. Then we want to combine any like terms that we have on the left or the right-hand side. I see some like terms here, so we can combine those. 1 plus 3n is greater than or equal to, and we'll go ahead and combine 4n and n. That's going to be 5n. And now we're going to go ahead and get the n's together on the same side. Well, I always want with inequalities the variable to be on the left-hand side. So I'm going to have to move this 5n over to the left. So minus 5n here and minus 5n here. And I get 1, and then 3n minus 5n is a minus 2n. The 5n minus 5n here on the right-hand side goes away, and I bring down the negative 4. Now, to get n by itself, we're going to have to get rid of this 1, so we do that by subtracting 1. And we get negative 2n is greater than or equal to, and then negative 4 minus 1 would be negative 5. Now, our very last step is to get rid of this negative 2. I notice that it's a negative number, so when I divide both sides by negative 2, I'm going to change the direction of that inequality. Negative 2 divided by negative 2 is 1. We're going to have the n here, and we're going to switch it from greater than or equal to less than or equal to, and then a negative and a negative is a positive. 5 halves can't be simplified any further. So our answer is n is less than or equal to 5 halves. I'd like you to pause the video now and try number 8 on your own, and then come back and check your answer. So now come back and check your answer. And number 8, the first thing we have to do is distribute. So that's our first line. And then we want to get the m's together on the left-hand side. So we subtract 6m from both sides. And then we have to get our constants to the right side, so we subtract 12 from both sides. And then our final step is to divide both sides by negative 12. Because it was a negative number, we had to change the direction of the inequality. So m is less than or equal to 2. In part 2, we're going to go ahead and write an inequality for each of these statements. A citizen of the United States must be at least 18 years old to vote. So I'm going to use the variable C for citizen. And if the citizen has to be at least 18 years old to vote, we need this citizen to be either equal to 18 or older than 18. So it has to be bigger than 18. So we do C is greater than or equal to 18. Number 10, the number of people seated in the classroom is at most 25 people. That means that no more than 25 people can fit in a classroom. So we're going to do P for people, and we know that it has to have at most 25 people. It can equal 25 or less than 25 to fit in the classroom. So P is less than or equal to 25. The length of a deck is at least 12 feet long. We'll make the length our L. If it's at least 12 feet long, it can equal 12, or it could be bigger than 12. So we do greater than or equal to 12. The store must sell at least $200 worth of merchandise a week to at least break even. So in other words, this store, and we'll call this X for the merchandise, must sell at least $200 worth of merchandise to break even. Therefore, they can make more than that, but that's the least amount that they can make. So they have to make more than or equal to $200. So X is greater than or equal to 200. Number 11, on the last 3 math tests, a student scored an 81, 85, and a 91. What score must the student earn on test number 4 to have an average above 85? Well, if you have the math scores of 81 plus 85 plus 91, and we add to it the 4th score, which we don't know yet, we'll call that 4th score X. If we were to add all those up and then divide by 4, that's how we'd find an average. So I'm going to take all of those and divide them by 4, and it has to be above an 85. So we'll write greater than 85. Well, to solve this, we want to go ahead and add all these numbers here in the numerator together. So 81 plus 85 plus 91 is 257. And then I'm going to rewrite the rest. Now, the next step is to get rid of this 4 here in the denominator. And we do that because we're dividing everything by 4. We can multiply both sides by 4. And therefore, this 4 and this 4 divide out. And we're left with 257 plus X greater than, and then 85 times 4 is going to be 340. Now we're going to go ahead and get rid of this 257 by subtracting 257 from both sides. And we get X is greater than, and then 340 minus 257 is 83. Therefore, a student must score above an 83 in order to have an average that's above an 85 on all 4 tests. Therefore, the score on test number 4 must be above an 83 so that the average on all 4 tests is above an 85. So I'll write here above an 83. Now, I'd like you to try number 12 on your own. It's done exactly the same way as number 11. Pause the video and then come back and check your answer. Now let's take a look at the answer for number 12. On the last 4 math tests, a student scores a 78, 92, 89, and a 92. What score must a student earn on test number 5 to have an average above 90? So we want to take the 78, the 92, the 89, and the 92 and add them all together. That's 351 plus one more score of X we're trying to find, all divided by 5. To find an average, we have to add all 5 test scores and then divide it by 5. So we have 351 plus X over 5 is greater than 90. We have to multiply both sides by 5. and then subtract 351 from both sides. So we get X, which is our test score for number 5, has to be above a 99. 13. John earns $400 a week plus an additional $50 for each magazine subscription he sells per week. If John wants to earn at least $1,000 this week, what is the minimum number of magazine subscriptions he must sell this week? Well, he gets $400 every week plus an additional $50 for every magazine subscription. So we have to take that 50 and we have to multiply it by X, which is our number of magazines he sells, and all of that has to be greater than or equal to $1,000. It can equal 1,000, or he could make more than that, but he has to make at least that amount. So to solve, we're going to go ahead and subtract 400 from both sides, and we get 50x is greater than or equal to, and then 1,000 minus 400 is 600, and then we want to divide both sides by 50. 50 divided by 50 goes away here, it turns to 1, and we get x is greater than or equal to, and then 600 divided by 50 is 12. Therefore, he must sell at least 12 magazine subscriptions to earn at least $1,000 this week. So he must sell at least 12 subscriptions.